All right, we are going to get started with our panel discussion today. Please, I'll remind folks, we're happy to have everybody chiming in here. The format is slightly different than our usual webinars, where we're trying to keep this a little bit more informal, have our folks share some of their thoughts and experiences with the audience here. And so please, if you have questions throughout, feel free to chime in. And looking forward to getting your thoughts as we move through. I'll try and pester the questions in throughout the conversation today. So with that, I'll start off by asking Ali Abedini to introduce himself.
Hi, everyone. I'm Ali. I'm the Executive VP of Operations at Interface Fluidics. My role at Interface is to be in charge of the commercial projects that we have here with our clients, and also leading our microfluidics development within the company. And my background is reservoir engineering. I did my PhD in EOR, phase behavior, and afterward, I was doing some research on the application of micro and nanofluidics at the University of Toronto. And now I've been with Interface for almost 5 years.
Excellent. Thanks, Ali. Next up, I'll ask Jelaine to introduce herself.
Hello, everyone. Hope you're doing well. I'm Jelaine Fortin. I'm the Senior Account Manager here at Interface Fluidics. My background is in chemical technology, and I have a degree in technology management. So basically what that means is I've done a lot of the conventional lab work that Interface Fluidics is familiar with, and some of the work that we've done to actually miniaturize those familiar tests onto our microfluidic devices. So a bit of experience in core flooding, slim tube, and a number of other analytical methods.
Excellent. Thanks, Jelaine. And last but not least, I'd love to introduce Curtis.
Good morning, everyone. I'm Curtis Fairhurst. I'm an account manager here at Interface Fluidics. So I've been here 4 months, so probably the newest member of this panel. And prior to joining Interface, I was a geologist in the oil and gas industry for 16 years, working Western Canada, a little bit into the States and Southeast Asia. So been on the client side with some of this, some of the core data. Pretty excited to be part of Interface Fluidics and be part of this innovative technology and work with clients to understand the challenges they face and how our technology can help provide solutions to their challenges.
Excellent. So when we were trying to conceptualize, ask ourselves, what do people want to hear about? What is something that we often get asked about? And I would say Curtis and his colleagues at our clients are often have the most questions of anybody that we work with. So, the thought was, how do we have that conversation with our geologist colleagues and friends? How do we talk about and think about our technology in relation to the real rock, which is, formed the bedrock of the oil and gas laboratory for decades or even longer than that. And so our goal today with this conversation is to share some of our perspectives, as well as talk a bit about how what we do is similar and how what we do is not similar to the traditional methods, and where the value can be extracted and why we do what we do. So the way we'll start off today is, the structure is, I'll start off to a general introduction to Interface and why do we exist. I'll pass it over to Ali, who can talk a bit about, from a reservoir engineering perspective, and the traditional methods that are out there. Jelaine can share some hands-on experience about what is the alternative and how do people work today. And then Curtis can share some of his thoughts and feelings as a geologist, take off his Interface hat for a few minutes and talk about what it's like to move from being a geologist primarily to a geologist secondary, maybe. So with that, I'll turn it over. And like I said, for those of you that are in the audience, please ask questions at any time. I'll try and integrate those into the process. So at the end of the day, the question we always ask ourselves at Interface is, why is fluid testing important? Why are we talking about this? Why does all of this exist? And fundamentally, what we believe at Interface is that fluid interactions and properties are a fundamentally complex subject with a lot of time being spent in traditionally on enhanced oil recovery and phase behavior or fluid characterization due to the cost associated with those very large projects. EOR and offshore are traditional, you're spending hundreds of millions or billions of dollars to extract the resource. Now that we're in a different paradigm with the shale revolution, fluid testing for those reservoirs has often taken a backseat due to the speed and repeatability that's required in those operations. And so what we're coming back from at Interface is saying, okay, how can we take fluid testing, which has traditionally been a bottleneck and is often seen as a fundamentally inaccessible data set. It's difficult to get due to time, logistics, cost, technical ability. There's a lot of reasons why people don't do fluid testing. And so how do we think about that at Interface, and how do we change the way people think about that? And so one of the biggest questions that people come to us with is, well, don't you need rock to simulate what's happening underground? Don't you need rock to accurately represent how those fluids behave and interact? And so that's the main topic here that we'll cover. The reason that people come to us at Interface, the solutions or the problems that we often try and solve is really removing risk from decision making. How do I look at my options, do a sort of objective analysis of what I could do, and then make a decision? And that's often around things like mitigating damage, increasing the yield of our wells, the return on investment of those wells. These days, one of the HS&E or environmental perspective is lowering emissions and fresh water usage, and altogether just speeding up the iteration process for whether it's hydraulic fracturing, enhanced oil recovery, or offshore primary recovery. These are all things that we are working with. There are drawbacks to not doing testing. And often what we see at Interface is the biggest drawback is surprises. Surprises are something that nobody particularly likes when we're spending millions of dollars. And so whether that's a surprise water incompatibility, that's a surprise cost associated with a new water source, or different chemistry that that was unexpected. And so our goal at Interface is to address the fact that if every reservoir is unique, the fluids that are in them are unique, and we need to find a way to bring that uniqueness into the day-to-day workflow of engineers and geologists. So with that, I'm going to turn it over to my friend Ali here to talk a bit about how are people working today, and what was their experience as a reservoir engineer before joining Interface?
Okay, thanks, Stuart. When we talk about the fluid analysis, right, we are basically talking about two pieces of this puzzle. One is the fluid data, basically what data is required, and the other piece is what are the basic measurement methods out that people actually use in the industry to collect those data. And I think when we look at the fluid analysis, we have to look at this term in a context of the reservoir lifespan during multiple stages of the production, right? I mean, when we talk about the primary production, we need some basic fluid properties, as people need to know that in order to basically forecast the performance of the reservoir during the primary. Majorly, there's some fluid data, including the bubble point, dew point, composition, those things. And also there's some other properties that we basically need in order to stimulate our wells during the primary production. For example, when we did acetizing, we need some information about that. Sometimes we use inhibitors in our wells, so there's some other fluid characteristics over there. And basically these are basically things that we require during the primary. Of course, there are other sources of the data that we can collect during the well drilling and logging, but I'm majorly looking at the lab testing or the lab data. The second part of it is when we do our post-primary production, either secondary, tertiary, we call it EOR. So you need more advanced fluid properties there. I mean, when you do gas injection, you possibly need some information regarding interaction of the gas and oil, such as the MMP, swelling data. When you basically do some chemical injection, you want to know what the compatibility of your injection fluid is versus your in situ fluid, and whether you see some damages or some sort of the reactions between the fluid happens or not. And for example, specifically in Canada, when we do the thermal processes, again, there are some other properties associated with thermal processes. So I guess there are two pieces here, basically during the primary and then the post-primary. And then, so when it comes to the measurements of these fluid properties, I guess in general, we have three big categories of fluid measurements. I guess the very first one is just the simple bottle testing, right? People just put two fluids together, they shake it, they see how they behave. Is there anything basically observable just visually, or maybe you just put it under a simple microscope, see what's going on. There are some other, basically the second piece to that is just some sort of the fluid characteristics, density, viscosity measurement, compositional analysis. These are fairly straightforward because it's not just related to oil and gas industry. I mean, other energy sectors or even other sectors outside of the energy, they also have similar measurements. And I would say the last one, which is more specific to oil and gas, is the special fluid analysis testing, which we really deal with the high pressure, high temperature samples or conditions that we have to measure those. And when it comes to the fluid data, just the, let's say the reservoir oil data, we're looking at the PVT cell, where we use in order to collect critical fluid information when we use it in order to basically forecast the performance of the reservoir. You put in your material balance equations to see, okay, how much left underground, how much produced, and then you want to re-estimate your reserve underground. We use basically high pressure, high temperature microscopy or spectroscopy method just to do some other niche measurements, such as the asphalting related measurements. We do the wax crystallization measurements, and those are basically very critical for the flow assurance. We have some sort of the scaling measurements, IFD, wettability or contact angle. So some of these measurements are also in conjunction with presence of the rock. And I guess, and the other category is just we do some testing in order to look at the fluid displacement when we actually either do the primary production or do the EUR, right? When I guess the king of that is the core flood, where basically you look at how your displacement behaves. I mean, how your recovery factor is going to be depending on the number of the variables you wanna look at, and see basically how your strategy works when you want to implement it into the reservoir. There are some other similar things. People do sandpack as well when the cores are not available. I'm not talking about the core stuff. Curtis can talk about more, but that's another alternative way just to just represent the porous media that you can flow things through the pore space. A slim tube is something else. People use it for MMP, but you either can do it for other related porous media measurements. And I guess we have the microfluidics as well, or all the school micromodels that have been in the industry for a few years, and I guess we can discuss in the next rounds. But I guess these are the frameworks of different testing here.
So Ali, I'm curious from your perspective, there's a lot of tiers of testing in there. There's some very complex, some very simple, some more representative, some less representative. When you're looking at us, when we talk to our clients about what testing is required for their particular application, what are the characteristics of the kinds of recommendations that you make? What are you looking for in a test, in its ability to answer those questions?
Yeah, I mean, to my knowledge, there's no silver bullet out, right? There's no test that can give all the information that you want. Basically, it's up to us to come up with let's say a flow chart that you can use it and get the maximum information from your testing platform. But so
you look at it from like a workflow perspective rather than a one test perspective.
Exactly, because there's no test that can give all the information out. I mean, but if you look at the testing characteristics, there were several pieces to that, right? I mean, some tests are easy, but I guess they're not very informative. Some of them are harder, but they're more, they can be a bit more informative. There are some repeatability, accessibility, and also the accuracy of the measurements here are important too. But I think it goes back to the clients, right? I mean, how much they want to know about their reservoir and how much they're willing to invest. I mean, as you mentioned, Stuart, some companies that don't pay attention to the testing, they directly go to the field, and then basically they may invest millions of dollars without getting a good result, but maybe by a fraction of that investment, they can get a more basically relevant data that can consequently basically change the direction of their actual implementation. I mean,
so here's a question about, last question I'll ask you before I go over to Curtis here, is about the importance of how, what does representative mean to you?
Yeah, I mean,
representative is the thing we get asked about a lot. Can you just talk a bit about what that means to you and how you approach that problem?
Yeah, I mean, to me, representative means how many parameters or how many variables of the actual process you can basically match or you can simulate within your lab testing, right? I mean, the more the better. So basically your system can be more representative. I mean, there were several aspects to that. I mean, one piece is the pressure, temperature, actual fluid sample, whether you can have all of these variables into your basically testing model. Can you run it at extremely high pressure? Because fluids behave differently sometimes in anomaly with what you think as you change the pressure, temperature. The other aspect to that is the level of the confinement. I mean, a lot of people run their testing in the let's say barrier core sample, and they expect to have the same results when they do into the shale or tight, but we know that confinement changes everything. And I get the other aspect to that, definitely geology and mineralogy, right? I mean, it's not just pure fluid, there's a fluid and rock together. So representative means how many parameters you can match in your system. So the more the better, but to me, these are the top three things that ideally we need to match here.
Great. And before I pass it over to you here, Curtis, I got a question, from one of the attendees here. There's a question about how we can validate our data without having the rock. I think that's a big question. I'm going to pass that one off to the end because I think that one has a potential to derail us pretty hard. The second one here is, can you measure rock fluid properties like rel perm, capillary pressure in our systems?
That's a good question, right? I mean, when we talk about the rel perm and capillary, the two things to that, right? Fluid, and fluid and rock, right? I mean, and in terms of the capillary pressure, I mean, as long as you can match the wettability, so, and if you have the right confinement, you can measure the capillary pressure. But rel perm, that's some sort both fluid and rock dependent. So if the rock fluid interaction is not well basically simulated, you still can measure your rel perm, but you possibly need to have some sort of modification to that if you want to incorporate it into the actual system.
Then there's some follow-ons to that that I will try to get to at the end of the session here. But with that, I'll pass it over to Curtis here. As I mentioned at the beginning, Curtis, we often get questions from our geologist friends that say, how do you know that you've got a representative system going on here? Show me the rock. Where's the rock? Can you just talk a bit about your perspective on that?
Yeah, for sure. So I might step back a little bit and just talk about the value of core and the rock is for those in the industry and working subsurface. And I wouldn't be much of a geologist if I didn't have a piece of core with me on my desk here as well. But anyways, the value of core is really fundamental to the subsurface team, and I think it's really important. Right off the top, to acknowledge that our tool and our technology isn't replacing isn't replacing core, right? Like core has a very valuable place. Geologists spend a lot of time in the core lab lifting box lids, looking at the sedimentary structures and debating what's going on from a depositional environment, how that influences their mapping and predictability of the reservoir and where to go next as far as exploration or development goes. So there's a ton of value in the core and looking at the core. And there's a ton of testing and analysis that can be done from the core. And that analysis can be used to calibrate well logs and petrophysics. It can be used to calibrate simulations and models. So the whole subsurface team uses core as a fundamental tool in their analysis and their ability to predict what's going on. And it is with that core, with the collection of core, there's a couple of challenges that occur, and one of them is the expense. Core is very expensive, and it's not always collected, depending on the company and their financial situation and willingness to collect the core. So core isn't always readily available. The analysis can be expensive, along with the rig time to collect it. The storage can be expensive as well. So there's a lot of expense around that. Also with core, picking the sample samples points and picking representative samples, depending on your facies distribution and how your rock characteristics change, trying to pick a representative sample can be challenging as well. And also in some jurisdictions like Alberta and maybe some others around the world, the ability to select plugs and do analysis can be limited as well. So, core is very valuable, and it's an extremely fundamental tool for the subsurface team, not just geologists, but the team. But it does come with some challenges, and I think that's where our technology can supplement the core and the analysis that you do with the core, and some of the advantages that we bring along with repeatability, and being able to run some of our tests at reservoir pressure and temperature, can be quite valuable when combined.
So to interrupt you for a second,
yeah, go ahead.
What is the fluid testing that geologists think about when you're thinking about fluid analysis or fluid compatibility or anything like that as a geologist? What are you like? What does that look like?
Yeah, so I think a lot of it is with formation damage. So if I can bring a real world experience from my past, water disposal from the shale boom has become an increasingly important part of the operation, and sometimes that injectivity changes over time. And understanding, is it the fluid that is interacting, causing some precipitation, creating that formation damage and really affecting the injectivity. So that's one example. Again, with the shale boom as well, like formation damage for production as well, right? So is the frac water and the chemistry that's being put down there, is that having a negative interaction with the porosity that might be affecting your ultimate recovery or the flow from that pore space? So from a geologist,
how are you answering that question on a daily basis? How do you confidently go to your management and say, I don't believe we have a compatibility issue here?
Well, you do some, if you have core, you try to do some core flooding, some tests if you have it. That's not always available. It's a difficult question to answer, and I think certainly in some jurisdictions it might be poorly understood, and I think that's where when I was looking to join Interface, thinking about my past and this tool to answer that question, that compatibility question, that formation damage question, being able to see how it interacts with the pore geometry, really appealed to me.
Yeah. Well, thanks for that perspective. We'll come back to you in a minute here. I wanted to sort of chat about with Jelaine here. You mentioned as in your intro that you've worked with these tools before. You've got a history of working with these tools. Can you expand a bit on sort of your experiences working with core, microfluidics, other tools in the lab, and sort of the benefits and drawbacks of those tools?
Yeah, for sure. Yeah, so as I mentioned, I've done a number of core floods in my past life. And I think to build off of what Curtis shared a little bit, definitely understand the value that there is in core, and maybe to just give a little bit of a story. So often when I would be doing core floods, there's such a time intensivity to set up the equipment and to make sure all of the initial conditions are correct, that we were almost afraid to do a core flood. So we would have, sometimes multiple weeks of delays, just going back and forth, discussing what do we really want to put through this core, because it's so important that we don't want to get the wrong experiment. And so I think when I moved over to Interface and saw how fast we could iterate, or how many tests we could do in a week's time, it was just like, wow, like you could do so many different combinations of chemistry and look at variables and really refine what you're wanting to look at, and then move over to something like a core that's so precious, and make sure you have a really good rock fluid analysis going on there.
Yeah. So you're talking to clients on a daily basis now. What is the most common, workflow, or like what is the question that we're often trying to answer? And like, how do you have this conversation with folks that are trying to get their head around how to reduce their risk?
Yeah, I mean, it's really hard to say there's one common workflow. I mean, I know we have some of our chemical vendor friends on the line, and that's a completely different workflow than from folks in unconventionals or folks in offshore. But I think ultimately people are wanting to have the best data they can in the shortest amount of time and the lowest cost. So I think what it really comes down to is looking at like what are the questions, what are the challenges that you have, and how would you answer them if you could? If you had a tool that enabled you to answer things really quickly, or at least eliminate a number of variables, where would you go? And I think that's something that we can do at Interface, is really help folks screen through a number of different questions really fast, so that the rest of their workflow makes even more sense.
Yeah, and Ali, you touched on this at the beginning about what a good test looks like, and you talked about how variables and control of variables is a hallmark of a good experiment. What is that often comes to a compromise, right? What variables are we willing to control and understand? And I think that's something we think about a lot at Interface, right? We're not necessarily including the real rock, but we are controlling for it in certain ways.
Yeah, I mean, I guess Jillian also touched on that a bit, but when you want to do fluid testing, you have some variables, right? I mean, pressure, temperature, fluid compatibility, and also confinement, rock, and other pieces, right? And at the same time, you can spend, let's say, years to get your fluid data, right? You have some certain budget and certain amount of time, so you want to get as much information as you can get. So if you ask me what would be the best, I mean, definitely you always have some very preliminary screening of these products and basically these chemistries out. So basically that part is something that most of the companies can acquire pretty fast. Now it goes back, do you want to jump to the very hard test with just very basic information? Because typically from very preliminary testing to the very actual testing, everything's going to change from fluid side, from operation side, and everything, right? I guess here the interface technology, microfluidics, can fill the gap really good, as Julian mentioned, right? So you can have most likely the pressure, temperature, the actual fluid that we have on the ground. So for example, you can do 10,000 PSI, 200 degrees C temperature. And at the same time, there is some sort of, let's say, some bottlenecks on the geology side, but at the same time we can match the wettability. We can actually have the true confinement, right, which is really critical. So you basically can have 80%, 75% of the total variables here. And at the same time, what you have that other core flooding or high P, high T testing don't have is just the speed. So what you can do a lot of screening tests, diagnostic testing through this technology, and just find what would be the range of the optimum conditions in terms of operational parameters. And now you get this into the actual testing, which basically comes from the core, right? So you have the true mineral, but at the same time, as Jelaine mentioned, you don't need to freak out because you don't know what to do with that core, right? You always have all the information from the other part, and then you can implement it on the core. So what I'm saying here is that we are not replacing the core flood or the special tools here. We are actually, our goal is to optimize the process in order to get the most valuable data from the core flood or some sort of the bigger scale testing.
I've got a question here from the audience from Ali, different Ali. You've all touched on formation damage as a major question that needs to be answered in many cases. He's specifically asking about CO2, enhanced oil recovery, and the interactions and possible damage from asphaltenes. Is that something we can look at? And maybe I'll sort of open up to anybody who wants to answer here, maybe asphaltenes specifically, but other, formation damage is a big bucket. Can talk a bit about that as well. So whoever wants to talk about some asphaltenes and CO2 EOR, go ahead.
Sure, I'll jump in. So yes, we can absolutely look at asphaltenes and the effect of different processes and impacting on asphaltene destabilization or a number of other things that could be crashing out and causing formation damage. So generally speaking, we do a lot of work with various chemistry to look at potential incompatibilities. We do a lot of water studies to look at water incompatibilities. So there you're potentially looking at, different salt precipitation. We also look at thermal dependency. So often if you're doing a beaker test and you shake two things up and let it sit, it might look okay. But then you bring it up to 300 or 400 degrees Fahrenheit and you start getting gummy bears or gunk dropping out. So I think that's another huge area that we address when it comes to formation damage, and then waxes as well. So I think, kind of going across the board, looking at really what could be happening and what could be reducing production and causing injectivity problems.
And maybe to piggyback on the back of that, from a production engineering, well, we're here to talk about geology for the most part, but from a production engineering perspective, anytime you have new wells coming online, mixing in your production system, the compatibility there does come into question. So from a flow assurance perspective, that's something we also do a lot of work on. So there's downhole fluid compatibility, but also from a process perspective. So with that, I have, I think Ali, you covered a pretty good idea there, a good summary of, why are we working through things? What is the workflow? What kinds of things are we covering? Jelaine, you talked a bit about sort of high pressure, high temperature and why that's important. Maybe I'll turn it over to everybody here to have one last perspective to share. If you can all just sort of give me one sentence on, if you're talking to your geologist friends, what are you talking to them about?
Well, I might have a little bit of a controversial statement, but the one thing that I would almost challenge folks to think about is that maybe your core floods aren't as representative as you think they are. And just from that perspective, what I mean is often we're using outcrops or, sand packs or a piece of core from somewhere sort of close to where we're looking. And it's very rarely the actual piece of rock that you will be producing from. So from that perspective, I would just challenge the assumption that core is always better. and be looking at alternative screening tools that really help you narrow down your fluid-fluid compatibility, fluid-fluid interactions, and then bring in the core for later studies.
Well, if anybody wants to get into it with Jelaine, your email's available, I'm sure.
I might add to that comment, and I don't think it's that controversial, Jelaine, because I think I mean, I can see why it might be initially, but when you think about some of the core that is available in industry, you know, sometimes it's collected, 30, 20 years ago. You know, what's happened as it sat in the box and has been modified over that length of time. What happens as it interacts with the drilling fluid while it's being cored? What's happened as its salt starts to precipitate as it dries out in the back of the trailer heading into the core lab, right? So I think your point is fair and valid, and certainly where this tool is a nice complement and helps de-risk that. And I think, you know, when I talk to my peers about our technology and our tool, I often find myself talking about de-risking and mitigating risk. And the industry is very much moving towards being more efficient and extracting more hydrocarbon out while spending less money. And I think that's wise. I think that's a good move that the industry is making. But to do that, you really need to mitigate risk as best you can. And I think this tool is really finely tuned to help mitigate that risk, or at least identify those risks and help mitigate them.
Excellent. Thanks, Curtis. Ali, what's your one take here?
We talk about the core, and we are slashing core flooding a lot, but it's not the case, I guess. I did core flooding in my PhD, and I guess core flooding is also very important, and it gives some data that honestly it's really hard to get from the others. But I guess I just want to touch on one more aspect here that I guess we didn't talk about here. Jelaine made a good point that basically we use some other cores and get some outcrop and stuff and use it and just predict or expect the same behavior on the ground. And the other aspect to that is your repeatability, right? Repeatability is not just on the data that you collect, but also it's on the initial condition of your testing, right? Typically, when you either have plenty of the cores, and cores can be different from one another to another. The other piece is if you use a single core, the core undergoes a lot of washing and saturation stages, right? And basically, you change some of the properties of the core itself as you make it ready for the testing, right? If it's a carbonate, it can have some reaction, so you may change some of the mineralogy. If it's got some organic matters, as you clean it with toluene, you basically dissolve those organic stuff. So I guess there's some sort of, it just goes back to the assumptions and how we're gonna test those assumptions, whether they're 100% valid or not. But I think core is important, rock is important, but we can't basically just stick to the core because fluid also matters. So that's my message to the geologist from reservoir engineering perspective, I guess.
Beautiful. All right. So I'd encourage anybody in the audience that still has questions. I've got a few questions here that, we have our internal list of here's the things everybody asks us all the time. So have we validated this against core floods? Can someone sort of chime in, have we done that? Where can we find the publications, or how do we show that off to folks?
So I'll jump in. So everything that we've developed at Interface Fluidics, first of all, we always develop our technology with industry partners, and then we always validate against conventional measurements and make sure that we are in line or exceeding the expectations there. When it comes to comparing our technology to core floods, we have a few publications out with SNF. I saw that they were on the line. So if you are familiar with the folks over at SNF, I would say go ahead and chat with them as well, or reach out and I can send you some of those publications. We've also done work with Rockwater, who's on the line. And then when it comes to the unconventional space, we also have a few publications there around looking at surfactant screening and other chemistry screening and how that correlates to conventional testing.
Great. Other question here. It's a bit the question I punted off to the end here. It's a bit in the weeds, but back to the relative permeability and capillary pressure questions here. Do we see end effects? How do we manage these issues? How does that sort of management process look compared to rock testing?
Yeah, I guess I need to jump in here. So we basically were discussing with one of our development engineers just yesterday or the day before yesterday about the rel perm and what are the associated aspects to that. I mean, capillary end effects, I mean, those things are very big basically topics, right? I mean, it's not, there are some theories out to simulate the capillary end effects, but at the same time, because there's no visual access to the capillary end effects within the core, so everything goes based on the assumption that you make, that you derive your rel perm and then the capillary end effect. In short, there's a capillary pressure, there's a rel perm, and capillary end effect is a part of this entire process. So within the chips, within the microfluidic patterns, basically, you can match the capillary pressure overall easily, because I mean, capillary pressure, as I mentioned, is dictated by just the wettability size of your confinement or geometry, and also the IFT between the fluid system. So what we are really good at, so we can match the fluid system pretty good. Pressure, temperature, confinement, and or geometry can also be tuned really well just to match the pore throat. And the wettability, I mean, we have some internal protocol that we can modify the wetting condition of the surface. So basically, you can you have the cosine theta, you have IFT, and you have radius. But when it comes to the rel perm, it's not just a capillary pressure driven, it also the rock geology driven as well, right? So basically how the system is going to behave in terms of the trapping mechanism. So that can be also a bit of rock dependent as well in addition to geometries. So we haven't measured or calculated the rel perm within our system. Two reasons. I still believe that even if I measure something, it can be used 100%. So people are going to tweak that, which is the same for other rel perm. The other thing is back to the capillary end effect. We haven't put much analysis on, but our system is too small. So my gut says, could part of this system can be impacted by the capillary end effects, which is going to basically obscure your rel perm. So we haven't done much stuff on that, but maybe at some point we can look into it again.
Excellent. Thanks, Ali. So with that, I'll call this panel here to a close. And I guess my last word here is it's really important for us to understand what we're measuring. Interface is all about the fluids. The one-liner that we like to talk about here is, at Interface, we measure fluid-fluid interactions. If you want to know about your fluid-rock interactions, we work with those folks, but we don't typically offer fluid-rock interactions. And, understanding our limitations and when it's right to pass it over to the core and how to pass it over to the core and how to run those experiments is something that we really specialize in. And so with that, I'll say thank you very much, and we'll be back next month with another topic and another discussion. So thank you very much, and have a great day, everybody.